Regulations. How do they work? Safety regulations and concerns. A video made by IB physics student Juan Guillermo Guerrero from English School Columbia. So how do they work? Nuclear power stations work by creating energy through nuclear reactions in order to heat up water. This water becomes steam, which makes this turbine rotate. Through the generator, this creates electricity for various usages. So how is energy created? First, the fuel. Uranium-235 is used in order to create massive amount of energies through fission. Fission means the splitting of the atom. How does this work? A neutron is shot into the uranium nucleus, making it split. The problem is, when it splits, it releases more neutrons, creating more chain reaction in which more atoms split. Now, this might seem good as more energy is created, but if the chain reaction continues to occur, enough energy is created in order to melt these rods, melt the vessel, and then create a radioactive leakage which could potentially destroy humanity. So how is this chain reaction controlled? These movable control rods, which are made of elements such as cadmium, hafnium, or boron, which absorb these neutrons, are used in order to maintain the chain reaction controlled by absorbing the neutrons, which we do not want to react with other uranium nuclei, thus creating a controlled reaction in which enough water is boiled in order to create the energy necessary. The elements are the fuel, uranium-235, moderator and coolant, which are used in order for fission to be possible and in order to prevent a nuclear core meltdown in which radioactivity is released into the environment because there's a failure on containing the reaction. Control rods, as I mentioned, pressure vessels, which contain the water, steam generator, in order to make this water steam, which will help rotate the turbine in order to create energy, and the containment structure to avoid any radioactive leakage. Now, safety concerns. First, nuclear meltdown of the core in which the structure is damaged and radioactivity is released. Nuclear wastes are very hard to control. They need to be stored in a very specific manner in order not to release this radioactivity into the environment. Nuclear disasters produced by uncontrolled disposal of waste, or environmental hazards such as earthquakes, which triggered, for instance, Fukushima, and national security issues, which encompass the creation of nuclear bombs. Now, IB questions. First, in the production of energy from nuclear fission, fuel enrichment means increasing in the fuel rods of amount of uranium-235, as we will see in a further question. In the ore, we find uranium-238, but it's not stable enough and not powerful enough in order to create the desired chain reaction, which would create a lower energy than what is needed. State the difference between a renewable and a non-renewable energy source. A renewable energy source is the one which relies on elements found in nature in order to produce energy, which would be, to a certain extent, limitless. A non-renewable energy, such as this one, relies on elements which are finite, like uranium-235. Two advantages of power production using fossil fuels in comparison to nuclear fuels. Although nuclear fuels might be cleaner as they don't dispose CO2 or greenhouse effect gases, the managing of wastes is harder and may create other problems such as radioactivity. Also, technology is safer and there is no military use in the case of fossil fuels. And fuel enrichment is necessary for fuel used in nuclear reactors because of what I said. In the ore, you can only find uranium-238, which is not useful. So enrichment is used in order to create uranium-235. Now, my time has passed for the video, but just if other students are gonna see this, they might want to consider these other questions. The reduction of energy is necessary because if there is a chain reaction which produces a lot of energy and a lot of heat, nuclear core meltdown may occur, and this would create radioactive leakages. Now, this is a question which is not directly encompassed by the topic, and this is why I didn't include it in the 4 minutes which are going to be graded. But this may be one of the type of questions an IB student may encounter. So we can see that these questions are not necessarily about the functioning of the exact way in which the nuclear reactor works. So you need to take into account that the questions in the IB are gonna relate different types of energy sources such as uranium or solar panels, and they're gonna play with your reading skills. For instance, in here it's mostly a question about thermal energy, but they ask what is the mass of uranium needed. You just need to know that this is joules per kilogram, and thus if you find the energy you can find the mass required. And the same goes for this question. So I hope you enjoyed the video.